Hello everyone, this is K. Prashant Babu, pursuing my BTech 4th year in Acharya Nagarjuna University. I have completed a project on microwave oven simulator on the platform Emertxe Information Technologies using Pixim Lab. Now going to the project details. The things we have learned in the internship are introduction to embedded systems, basics of C programming, and we have taught about the interfaces of LED, digital keypad, buzzers, and CCLD. And we have also simulated these all are simulated using Pixim Lab. We have also studied about some of the basic programs of embedded C programs on microwave oven. Embedded systems. An embedded system is a microprocessor or microcontroller based system of hardware and software designed to perform a specific function with a larger mechanical or electrical systems. For examples, microwaves, ATMs, mobile phones, and digital cameras are some examples. Types of embedded systems. We have four types of embedded systems: real-time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. Now, coming to the embedded system components, we have the block diagram of embedded systems here. Here, the main part of the embedded systems is CPU, where all the other elements are connected to it. First, we have the sensors. Sensors read the information and values of the surrounding values, and the values are in the analog form. This analog form are converted into digital form using digital A to D converters. This digital conversion is stored in CPU, and this CPU has memory allocation, where memory can be stored or retrieved or stored, as it's a bidirectional. And we have also created a software to control this the CPU. Next, we have the user interface. As we have discussed earlier, we have some of the user interfaces like CLCD and LED, buzzers, and some of the user interface. As the processing is in the analog digital form, we need to have the output in the digital form. So we use digital to analog converters. Now, and to all we are being studied in different places, we experience a different atmospheric conditions. As some of the cases like Jammu and Kashmir, there may be a high temperature of very low temperatures, and whereas in some of the parts like Rajasthan and other parts, there is a massive heat amount. So to fluctuate or to have a balance between the temperature, also we have an external environment connected to the sensors and actuators. So these take care about the sensing part and the values detection, and in any situation. Software used here, MPLab IDE is used. MPLab is a priority free fire integrated development environment for the development of embedded system applications on PIC or DISPIC microcontrollers and developed by the microchip technology. MPLab X is the latest edition of MPLab and developed on the NetBeans platform. Pixim simulator. We have used the Pixim simulator for our project of microwave oven, and the simulator is real-time emulator of the development boards with integrated MPLab debugger. Pixim supports some of the Pixim's controllers and some microcontrollers. Pixim Lab has an integration with Pixim Lab Arduino IDE for programming the boards and controllers. Next, this is the outline program for microwave oven. Next, moving to the next slide, microwave oven simulator. Here we have some of the functions or the keys we have to use on the microwave simulator. First, power on. This denotes that we need to LCD display has to be turned on. Next, cooking modes. There are four types of cooking modes. One is micro mode, grill mode, convention mode, and start. Set time temperature. The oven needs to facilitate the user input required to the time or temperature. So the set time or set temperature is used for the calculation of amount of time or temperature has to be given to the oven as an input. Issue warning: if the input has been exceeded or the temperature has been exceeded or any other software interrupt has been occurred, we need to get displayed about the issue warning. This is called issue warning. And whenever the cooking time has been ended or the temperature exceeded, it need to be ended. So this is end time. Functional requirement. The functional requirement: on powering on the micro oven, CLCD displays the power on and messages the followed statement of 4 different types of cooking models. So as we have discovered about the 4 cooking models earlier, so we have grill mode here, micro mode, grill mode, convention mode, and start mode will be displayed on the CLCD display. Now the functional micro mode. Micro mode, on pressing the key of micro mode, we have the 2 types of display. Firstly, we have a display of 900 microvolts, so that how much time we need to give the setup time. We need to set up the time of how many minutes and seconds, and we need to clear. For star we need to clear, and hash we need to enter. There are 2 buttons in the shown in the display for the micro mode. Next, moving to the functional mode. In the functional mode, next we also have 4 types of keys here, 3 types of keys here: start, pause, and end. Here the 4th key is given as the start or pause time, start or resume time. Our 5th key is mentioned as pause time, and 6th key is mentioned as end time. Here, whereas if we click on the key number 4 or start or resume, the cooking time will take 30 seconds more, and or it adds the time input timer to 30 seconds more. And whenever the key 5 or the pause is pressed on it, the timer and fan stops. And if you want to resume the cooking, again we need to press number 4. And finally, after the cooking, we need to press on end. So the cooking time up. It shows it on the display of cooking time up. Next, moving to the next mode, grill mode. The grill mode is also a set. We need to give a input time in minutes and seconds, and here also we have 2 buttons of star and hash displayed on the CLCD, so that we can, if you want to clear the data or anything, or if you want to enter the data by clicking these 2 buttons, we can restore the data. Next, coming to start, and as we have discussed earlier, similar functions of start, pause, and end are in the grill mode. Next, convention mode. As we have discussed about the two modes before. The 2 modes are defined on the basis of input time. Now the convention mode depends on the input temperature that we have given. Now on pressing the key 3 in the matrix keypad, we can see of 2 types of clear and enter, and temperature. Here we need to give the temperature in degrees, so that our cooking time will be the inside the oven, the temperature will be measured, and after the temperature has reached the threshold, it cuts off. Now this oven starts preheating with a given temperature for 3 minutes. So first only the oven starts preheating itself before the 3 minutes. Next, functional requirement. On pressing key number 4 in the matrix keypad, start mode is selected. Cooking time is set to 30 seconds, and cooking starts automatically. So as we have discussed before, the start button, whenever we click the start button or the resume mode, we have 30 seconds extra for the cooking time, so that the cooking requirement for the oven is increased. And whenever we click the pause button, the function stops, and the fan rotation also stops. by clicking number 6, the process will be end. Now my friend Padava will continue the next slide of interfacing.
Hi everyone, I am Goli Parthiva from Acharya Nagarjuna University. Presently, I am intern at emertextechnologies.com. Previously, my friend has been explained detailedly about what are embedded systems and how microwave oven was connected, how microwave oven was operated. In this lecture, I am going to tell about the interfacing about microwave oven with various components. Initially, in this project, I have used PIC 16F877A IC. The architecture of PIC 1677A IC has shown here. This IC has five input ports and 15 interrupts, 3 timers with 8 KB flash memory and also 368 bytes of data memory. This can be interfaced with various components like LED, buzzer, digital keyboard, SSDs, matrix keyboard, and CLCD display, and so on. The next component was CLCD display. CLCD stands for Character Liquid Crystal Display. It has two types of displays, 16 by 2 and 16 by 4. In our project, we used 16 by 4 display. It has total 16 interfacing lines. D0 to D7 are data lines. It has built-in controller. It has ohm ROM and ohm RAM that can control using instruction and data. Uh, RS line is known as register select line in CLCD display. RS value is set to 1, then it will take as data, and if RS value has set as 0, it will take as instruction. Data processed by two methods, delay method and polling method. Polling method means we want to observe a pin, in our case D7 pin. It will read and write the um, data providing by us. If we set R by W pin to 1, it will read, and if we set R by W pin to 0, it will take the input as read. In CLCD display, D0 to D7 are connected to port D, and RS and enable pin are connected to port E. In 8-bit CLCD display, the data pins are from D0 to D7. In 4-bit mode, there are D4 to D7 data pins. This is the CLCD display as shown in figure. D0 to D7 are data pins. RW is known as read or write pin and E is known as enable pin. Now coming to tactile key. Tactile key is a switch that allows electricity in flow in a electrical circuit by manually pressing the operation section. The switch is used to supply input signal to activate a device or equipment. It is designed with a small footprint suited for mounting onto the surface of printed circuit boards, made to connect electronic components to form electronic circuits. The switch activates when passes and then turn off when releases. This action is called momentary action and can be performed at low voltage and low current. There are many different types of tactile switches that are also known as tactile push switch or tact switch in variety of applications. Uh, the tactile switch was used in variety of applications including household appliances, office equipments, commercial equipments, and industrial machinery. Uh, in this figure, it has shown about the working of tactile switch. This is the switch, and when we press, it will allows the flow of electricity from input to output. When we release a switch, the bouncing effect will bounces the switch back to its off state. So when we release, the flow of electricity will be cancelled. This is the matrix arrangement of tactile switch in the keypad of microcontroller. There are total 4 rows and 3 columns in the switch, which were connected to the microcontroller. The next topic is about timers. These are three types of timers. They are timer 0, timer 1, and timer 2. Timer can work as timer and controller like counting internal and external pulses. Timer 0 is a 8-bit timer, like it will count from 00 to FF. FF means here a hexadecimal number which indicates 00000000, then generates an interrupt. There are various registers associated with timer 0 like TMRO clock source select bit. There are 15 interrupt sources in case of this microcontroller. Timer 0 has a bit GIE. If we set this bit, it will enable all interrupts. GIE bit is commonly known for all functions, whether main.c or timer.c. Interrupts. Interrupt occurs when the timer 2 register overflows. Buzzer and fan. Buzzer connected to pin 1 of port C, fan connected to pin 2 of port C. Buzzer indicates that the process has been overflowed or the process have completed. The fan will turn on when the process will start. Now the project will explain about my friend Balaji.
Hello everyone, this is Balaji, BTech final year in the stream of Electronics and Communication at Acharya University College of Engineering and Technology. I am doing intern at Emertxe Information Technology in Embedded Systems and Microcontrollers. We are doing project recording microwave oven using microcontroller and Emertxe. Let us see how the project. Much okay. So the project has been loaded successfully. So ahead and turn on the microwave OV by the pressing the set button, and the here the four cooking modes is being displayed, and the micro made first the power and 4 minutes I can head and I clear the main and the seconds. I can also go ahead and enter the time again and hit and enter. So now for the timer fan has been started running. I can click on the key file to pass the cooking and again on key 4 to resume the cooking. Now in this part we are considering the button RT3 has an outdoor button, so whenever the button is being pressed it means that the door is open, and whenever it is released it means the door is closed. So let me go ahead and open the door. Now the buzzer and the CLCD both be indicating same that the door is open and ask the user to close the door. I can hit on the 6 key and end the cooking process. Now the CLCD will jump back to the cooking mode display again. Let me turn on micro mode again and enter a random cooking timer. So here it goes, and so on. As the timer goes down to 0, the buzzer and this CCD cooking shows time up. Now let me go ahead and implement the grill mode. The grill mode function will remain same as the micro. Same as the mode, I can enter some random numbers like 23. The timer and fan both will be started again. I can pause the cooking by pressing key 5 and the resume the pressing key 4. I can also the end the cooking by pressing hit on key 6. As soon as the timer goes down to 0, the CLCD will indicate that the time is up. Now the cooking process is done. Next is the convection mode. So let me go ahead and implement that. So in the convection mode, the CLCD will promote the user to enter the temperature value. So the oven accepts the temperature value which is less than or equal to 250 degrees Celsius only. So any value we enter which is beyond 250 degrees, the oven will throw as a warning saying that the temperature is invalid. Let me enter the wrong value of temperature first, which is beyond 250, that's 500, and it shows now the timer is showing invalid warning. Let me enter the temperature, say 220 degrees Celsius, and hit on enter. So now the oven will start preheating for 180 degrees seconds 180 seconds or 3 minutes for 220 degrees Celsius. Let's wait for a 165 more seconds. When the preheating time goes down to 0, the CLCD will promote us to enter cooking time. Let me go ahead and enter this some random value of time. Let's say 40 or 45 seconds and hit enter. The key values of 4 or 5 and the 6 will remain the same. As you can see that 5 will pass, the cooking 4 will resume, and 6 will the end the cooking. Now let me go ahead and implement the start mode. For that I have to press 4. As soon as I press for the cooking time will set automatically to 30 seconds. If I press 4 again, then the cooking mode will keep in incrementing by 30 seconds. So as I press 4, it can pass it by passing 5, resume it pressing 4, and end it by pressing 6. So this is was about my internship project, that is microwave oven simulator. Thank you.